Let's quickly go over what the static life index is and give a real life example to see how it's used. Simply put, the static life index, sometimes called RP ratio, is a measure of the expected lifetime of a resource. Looking at the equation, we can see why it's called the RP ratio, because we divide the reserves R over the present production rate P. If we're missing the present production data, sometimes you'll find that the present consumption rate is substituted in with the understanding that the two aren't exactly equivalent. To see how this estimate is performed, let's find the expected lifetime of lithium in Brazil based off the 2021 data. The reserves at the time were 95,000 tons, and the present production rate was 1.5 thousand tons. Substituting in the numbers, we see that the units cancel out, and we're left with 63 years, which, from 2021, places the expected date at around 2084. Looking at the table from BP Statistics, we can see how the estimate of 63 years stacks up against some of the other countries. And of course, this principle can be applied to other resources, such as oil reserves. The biggest drawback, however, with using the static life index is, as the name implies, it doesn't take into account the dynamics of reality, such as changes in growth rate. And looking at the data, we can see that the present production rate doesn't remain constant and is something that other models take into account, which we might explore in a later video.